Welcome back, dear students. So today we are going to see some of the very important questions on differentiation. So that's why I'm calling it miscellaneous problems. Now question says, find dy by dx using this rule. Now this rule is nothing but chain rule. Suppose if this is not mentioned, you can use your chain rule to find dy by dx for these kind of functions. Okay, now to make use of this rule, let's observe here carefully. First you are differentiating y, that is this one. Okay, so first when you differentiate this, you will start from the outermost part. Okay, so that's why this cos inverse is your y. Okay, and whatever is inside this will be your u. Okay, so that's how we have to work. Or in other word, the simplest thing which we can do here is we are differentiating v at last, right? So that's why in chain rule we are going to differentiate whichever is inside this, that is the innermost function, will be differentiated last. So that's why my innermost function is going to be my v. Okay, so that's why I'm writing let v is equals to 2x minus 3. Okay, now we need to find dv by dx. That means we need to differentiate v with respect to x, v with respect to x. Okay, so that's why if I differentiate with respect to x, then I'll get dv by dx equals to differentiation of this will be 2, right? So 2 will be kept outside because this is constant, and differentiation of x is 1. Okay, now dv by dx is 2. Now we have differentiated this. Now after this is root over function, right? So that's why this root over function will be my next function, that is u. Okay, so that's why I'm going to take this to be u to be root over. Now I cannot write 2x minus 3 because 2x minus 3 is equals to v. So that's why I'm taking u to be root over v. Okay, now we need to find differentiation of u with respect to v. Differentiation of u with respect to v. So differentiation of u with respect to v, that is differentiating both sides with respect to v. What are we going to get? So this is v to the power half. So it's going to be half v to the power half minus 1, which is 1 by root over 2 root over v. Okay, now the last one, we have differentiated this. Now the last one is cos inverse. Okay, and that cos inverse is going to be my y. So y equals to cos inverse of, now I won't write this full thing, and we know that this full thing is square root function is u, right? Okay, and 2x minus 3 is v. So basically this is root over v. So root over v can be written as u. Okay, now we need to find dy by du, right? So differentiating both sides with respect to u, then I'll get dy by du equals to, now differentiation of cos inverse is minus 1 by root over 1 minus u squared. Okay, now let us put back these values in this. So therefore we'll get dy by dx equals to dy by du into du by dv into dv by dx. Now let us put the values. So dy by du is this much, minus 1 by root over 1 minus u square into du by dv. Du by dv is this much, that is 1 by 2 square root of v into last one dv by dx. dv by dx is 2, right? So 2 and 2 gets cancelled, so minus. Okay, so these two roots can be combined, so this can be written as root over v into 1 minus u square. And what is the value of u square from here? U square is v, right? So that's why instead of this I'm going to write v. Okay, and ultimately we have minus 1 by root over v. How much is v? V is 2x minus 3. So instead of this I am writing 2x minus 3, and 1 minus v will be, from here we will see 1 minus v is going to be 1 minus 2x minus 3. That is going to be 4 minus 2x. So that's why I have 4 minus 2x out there. So this is going to be the dy by dx. Okay, so pause the video to note down. Okay, now similarly let us check how to find dy by dx of this function using this formula. Now as I said, the innermost has to be taken as the last function, right? So here 2x minus 3 was the innermost, so that's why I took this to be v, the last function. Now the innermost function here is x cube, so that's why I am going to take this to be v. So let v is equals to x cube. Now when you find v, you need to differentiate v with respect to x, so that's why you'll get dv by dx. That means the derivative of x cube is 3x squared. Okay, now we have finished our work with x cube. Now the outer function is sine, so that's why I'm going to take this to be u. So u is equals to sine of x cube, and x cube is how much? V. So this is sine v. Now I need to differentiate u with respect to v. So differentiation of u with respect to v, that is derivative of sine, is going to be cos v, right? Okay, now let us put the last function, that is after sine is log with the base 2, so that's why this is going to be my y. So y is log, and this full function, that is sine x cube, that is sine v, is u, so that's why it's going to be 2. Okay, now before we differentiate this, that is before we find dy by du, we have to be careful, because as I said, there's a function, there's a formula which says dy by dx is of log x is going to be 1 by x. Okay, so to put this formula here, the base has to be e, right? But here we have got base as 2. Now that's why I'm going to put one very important formula here. I'm going to change the base. So if you have somewhat like this, then the formula to remember this is very simple. So log b will be kept in the numerator. This is in the upper position compared to a, so that's why this will come in the numerator. This is in the lower position, that's why this will come in the b. Okay, and you can introduce any new base of your choice here. I am putting c here. Okay, so this is one very important formula. So this is the formula which I am going to make use out here. So we have, first we'll write log u. Okay, log 2 will come in the denominator. Now I can write any base of my own choice, and I'm interested with base e, so that's why I'm writing base to be e out there. Okay, so whenever I do that, e is also a constant, right? Exponential, so e is also constant, and 2 is also constant, so this full thing becomes my constant. Okay, now let us find dy by du from here. So dy by du will be, now since 1 by this is constant, so that's why this will be kept outside. So we have this one as constant. Now differentiation of log with base e of u is going to be 1 by u. So 1 by u means it will be this much. Okay, now let us combine all these things here. So therefore dy by dx. Now I'm not going to write the formula. So first is dy by du, and dy by du is 1 by u log 2 with base e. So dy by du is here. Next is du by dv. So du by dv is cos v, yes, into, now the last part is, okay, the last one is dv by dx. So dv by dx is 3x squared. Now let us put back the values here. So what is u? U is sine v, right? So first substitute u. So u is sine v. So cos v by sine v becomes cot v, right? And this 3x squared can be written in front. Okay, so you can write reasons. So u equals to sine v, and cos v by sine v is cot v. Okay, so 3x is written, cos by sine, that is cot v is written, by log 2 with base e. Okay, so there is one more formula which says log b with base a can be written as 1 by, okay, so you can interchange the base. Okay, so b will come here and a will come here. So if I make use of this formula here, so 1 by this log is there, so if I keep it in the numerator, this base and this number will exchange their position. So we have 3x squared cot v, and v is how much? V is x cube. So x cube, and this will go up to become log e with base 2. So this will be my answer. So pause the video to note down. Okay, so in the next question, again we need to differentiate and find dy by dx. Now here we can make use of a differentiation of f by g kind of function. Okay, where you will write g square in the denominator and we have to do some kind of things in the numerator. So instead of using that formula, we can make our work a bit simple by applying log. Okay, so why we are going to apply log, we'll see through this example. So applying log on both sides, we'll get log y, right? So log a by b, and we know that log a by b can be written as log a minus log b. So first let me put this formula here. So if I do that, I'll get log of a, that is numerator is x cube into square root of x square minus 12 minus, okay, so b is log, that is denominator, that is cube root of 20 minus 3x. Okay, now there's one more formula, that is log ab can be written as log a plus log b, right? So this is one more formula. Since there is into sign here, so that's why I'm going to make use of this formula here. So we have log x cube plus log square root of x square minus 12 minus log, now this is cube root of 20 minus 3x. Now there's one more formula which can be used here. So log a to the power b can be written as b log a, right? So power comes front. So power is 3 here, so this can be written in front. So this is log 3 log x plus, similarly here the power is half. So half can be written in front. So half log of x square minus 12 minus, now here the power is 1 by 3. So this 1 by 3 can be written here. So we have log 20 minus 3x. Okay, now let us differentiate both sides with respect to x. So whenever I differentiate, differentiation of log y will be 1 by y into dy by dx, right? So 3 into the differentiation of x is log x is 1 by x, so that's why it becomes 3 by x here, plus half into, now differentiation of log becomes 1 by something, and that something is x squared minus 12. Now we need to differentiate this inner one, that is differentiation of x squared will be 2x, and 12 becomes 0, so that's why it becomes only 2x out there, right? Similarly minus 1 by 3, differentiation of log, this becomes 1 by 20 minus 3x into, now we need to differentiate this as well. So differentiation of 20 will be 0, and a minus 3x is going to be minus 3. Okay, now let's simplify this. So after simplifying, let us see what do we get. So we have 3 by x. So this 2 and 2 are getting cancelled. Similarly, this 3 and 3 are getting cancelled. So we have plus x by x square minus 12. Okay, minus into minus is plus. So in the numerator we have got only 1, 20 minus 3x. Okay, so this is after simplifying. Now if I keep only dy by dx out there, because my aim is to find dy by dx, I'll take this y in the numerator. Okay, so whenever this comes to this side, it becomes y, right? And what is the value of y? That is x cube into root over x square minus 12 divided by cube root of 20 minus 3x. So this is the value of my dy by dx here. But the question says we need to find dy by dx when x is equals to 4. Okay, so therefore dy by dx when x is equals to 4. So let us check how much is this. So x is 4, so wherever x is there, we'll put 4. So we have 4 cube root over 4 square minus 12 cube root of 20 minus 3 into 4 is 12. Similarly, 3 by 4 plus 4 by 4 square, that is 16 minus 12 plus 1 by 20 minus 3 into 4, that is 12. So let us simplify this. So this is 4 square, so that is 16. So 16 minus 12 is 4. So square root of 4 is 2 and 4 cube is 64. So 4 cube is 64 and square root of 4 is 2. So similarly we have 20 minus 4 is 20 minus 12 is 8 and cube root of 8 is 2. Simplify the inner one, that is 3 by 4. 16 minus 12 is 4, so 4 by 4 is 1, so plus 1 plus similarly 1 by 8. Okay, so 2 and 2 gets cancelled, so 64 into, let us simplify this, so the LCM is 8. So divide 8 by 4, that is 2. 2 into 3 is 6 plus 8 plus 1, that is 64 into, if you add them you'll get 15 by 8. Okay, 8 ones are 8, 8 plus 64, so 8 into 15 is 120. Okay, so this will be your value for dy by dx when x is equals to 4. So pause the video to note down. Okay, so next we are going to see is this problem. So we need to find dy by dx, and the question seems to be a bit tough, but it's not so tough. Okay, how? Let's try to understand. Now this question is being complicated only because of this square root part. Okay, but this is nothing but a constant, because here it is only a and b being used, and our aim is to find dy by dx. Our aim is to find dy by dx, and here the variable is going to be only x, right? So that's why this whole thing is going to be my constant. So again, let's make use of our chain rule. So differentiating both sides with respect to x, then I'll get dy by dx is equals to, so let us begin from the outermost part. This is tan inverse. Okay, so differentiation of tan inverse is 1 by 1 plus x square, and here this full thing is my x. Okay, so that's why I'll get 1 by 1 plus x square, so this full thing is my x. So square root of a minus b by a plus b tan x by 2 square. Okay, so differentiation of tan inverse is done. Now we need to multiply it, and we need to differentiate this inner one. And to differentiate inner one, we know that this is constant, so that's why this will be kept outside. This will not be differentiated. Okay, now we need to differentiate tan x by 2. Now differentiation of tan is sec square, right? So it will be sec square, angle is x by 2, okay, into, now we need to differentiate x by 2 as well. Now differentiation of x by 2 can be written as, this 1 by 2 will be kept outside because this is constant, and we need to differentiate x, and this will be 1 by 2 into 1, that is 1 by 2. So that's why it will be 1 by 2 out there. Okay, so we have successfully differentiated, but you can simplify this further. So let's see how to simplify this. So we have, so 1 by 1 plus, okay, so square and square root sign will vanish, so you will have 1 minus b, so a minus b by a plus b tan square x by 2 into, so you have a minus b by a plus b sec square x by 2 into half. Okay, so similarly, when you simplify this, what you are going to say is this a plus b will go to the numerator, right? So here in the place of 1 you will get a plus b plus, here you have a minus b tan square x by 2. Okay, hope this is clear to you. Now remaining thing is again the same, that is root over a minus b by a plus b sec square x by 2 into half. Now in the numerator we have got a plus b, right? And this a plus b can be in fact written as this much, right? Okay, so basically you have root over a plus b whole square. So here also in the denominator you have got root over a plus b, right? So in fact you can write this way. Okay, so this root over a plus b and this root over a plus b will cancel each other. Okay, so in the numerator now we have, in the numerator we have root over a plus b here, and this a minus b can be combined, right? Okay, now let us see what is happening in the denominator. So if I open the bracket, then I can write a as common, and if I take a as common, then from here I have got 1 as remaining. Now from here, if a is outside, then we have plus tan square x by 2 remaining, right? Similarly we have got b here, so if I write b here, then I have from here 1, and from here we have minus tan square x by 2. Alright, so similarly we have here sec square x by 2 into half remaining. Okay, so what is the value of this? This means that we have a plus b into a minus b is a square minus b square, right? Okay, so similarly we have, if you see here carefully, we have 1 plus tan square theta is sec square theta. So instead of this I can write a sec square x by 2 plus, we can keep it as it is. Okay, so because we don't have any formula for this, 1 minus tan square x by 2. Alright, so this sec square x by 2 can be written in the numerator. Sec square x by 2 can be written in the numerator, and this half can be kept in front. So this gives you your dy by dx. Okay, so pause the video to note down. Okay, now let's check with this question. So again we need to find dy by dx. So as usual we are going to make use of chain rule here. Okay, so let's see what happens if I use chain rule. So then we'll get dy by dx will be, now let's see what is differentiation of cos inverse x. So d by dx of cos inverse x is minus root over 1 minus x square. So this is this entire thing is my x for me, so that's why I'll get negative of 1 by root over 1 minus x square, and x is a plus b cos x by b plus a cos x, and this is square, so that's why I'm writing square out there. Okay, so this is about your cos inverse. Now let us move inside. So inside we have got a by b or f by g format. So whenever we have got f by g, we need to first write square of denominator in the denominator, that is b plus a cos x whole square. Now whichever was in the denominator, that will be kept as it is, that is g will be kept as it is. Now we need to differentiate the numerator, so that is d by dx of a plus b cos x. Right, now we'll put negative sign. Now we'll reverse the process, that is a plus b cos x will be kept as it is, and we need to differentiate the denominator, that is b plus a cos x. Let us simplify this further. So we'll get negative. So when you simplify only this part, then in the denominator we have got b plus a cos x whole square, since whole square is there, minus a plus b cos x whole square. Right, now still we'll be having in the denominator b plus a cos x whole square, but square root of b plus a cos x whole square is going to be b plus a cos x, so that's why this b plus a cos x will come in the denominator, but this will go in front on the numerator, so that's why we have b plus a cos x. Right, so this is simplification of this part. Now in the denominator we have the same thing, that is b plus a cos x whole square. So simplify the numerator cos x. Now differentiate this part. So differentiation of a is going to be 0, so let's not write that. Now differentiation of b cos x. Now b is constant, so that's why it will be kept as common, and differentiation of cos x is minus sin x. Right, so minus is there. Similarly a plus b cos x. Now differentiation of b plus a cos x is similarly going to be minus a sin x. Okay, now this and this can be cancelled. There are two b plus a cos x square whole square here, so that's why one of them will get cancelled. Now let us simplify this. So we have minus 1 by, okay, so let us open this bracket. Okay, so if I do that, this is a plus b whole square, so a plus b whole square can be written as a square plus 2b into a plus b into a cos x becomes ab cos x plus b square. B square is a square cos square x. Right, okay, now let us write formula for this. This is again a plus b whole square, so a plus b whole square is a square plus 2ab plus b square, but because of this minus, all the signs will get reversed. So minus, similarly you have 2ab cos x minus b square cos square x. Okay, now here we have got 1, so this 1 into this whole thing will remain the same, right? So this will be remaining as it is, so that's why I'm multiplying and opening the bracket. So minus b into b becomes minus b square, and we have got sin x as well, so sin x. Okay, minus into plus is minus, so a into b is ab, sin x into cos x is sin x cos x. Now minus into minus is plus. Okay, so that's why it's going to be plus a into a squared sin x. Okay, a into b, sin is plus, so a into b is ab sin x cos x. Okay, and there is one more term left out there, that is b plus a cos x. Let us see what are the things which are getting cancelled. So this and this are getting cancelled, right? Similarly, this and this are getting cancelled, right? Okay, so here we have got minus. Here you can multiply this minus with the numerator and you will get a square becomes minus and this b square becomes plus. So you'll have b square minus a square, and since sin x is common, so I'm writing sin x as common. Okay, so in the denominator we have, if I take this b square as common, so we have 1 from here, and from here we have got minus cos square x. Okay, so this is about your b square. And similarly, if I take minus a square as common, then from here you have got 1, and from here we have got minus cos square x as common, right? Similarly, you have b plus a cos x, which is kept as it is. So 1 minus cos square x is this sin square x, this is also sin square x. So again sin square x is common, so square root of sin square x is, okay, sin x. So that's why you have sin x kept outside, so sin x is outside. Okay, so if sin x is kept outside, so you have b square minus a square here, and here we have b plus a cos x, right? So this again can be written as root over b square minus a square whole square, and we have got sin x here. So sin x and sin x can be removed, this and this can be removed, so ultimately what is left? So we are left with b square minus a square divided by b plus a cos x, right? So this will be our dy by dx. So pause the video to note down. Okay, so question says, if y into root over x squared plus 1 equals to log root over x squared plus 1 minus x, we need to show this. So basically we need to find dy by dx, right? So to find dy by dx, let me keep only y out here and let me keep this x to the other side. So from here, what do I see? I see that y is equal to log of x squared plus 1 minus x by the square root of x squared plus 1 goes to the denominator, right? So differentiating both sides with respect to x, then I'll see in the left hand side dy by dx. So this is f by g form. So f by g can be written as denominator squared. So denominator square is, this one is my denominator and it's square, right? Okay, now so denominator will stay as it is. Now we need to differentiate the numerator, that is x squared plus 1 minus x minus, now this will remain as it is, so log of x squared plus 1 minus x d by dx of this one now, that is x squared plus 1, right? Okay, now next this and this will get cancelled, so we have x squared plus 1, and let me take this x squared plus 1 here, because with the dy by dx we have got x squared plus 1. So if I do that, then I have x squared plus 1 dy by dx equals to, let's simplify this, so we have root over x squared plus 1. Now let's differentiate this one. So differentiation of log will be, okay, so this is for this whole thing, right? So differentiation of log will be 1 by something, and what is that something here? Root over x square plus 1 minus x. Okay, now this is for your log. Now we need to differentiate this inner part as well, right? So let us differentiate this one. So differentiation of this power, this is power is 1 by 2, so it will be half into x square plus 1 to the power minus half. Half minus 1 is minus half. Now we need to differentiate x square plus 1. So into differentiation of x square will be 2x, right? So differentiation of x square is 2x, and for 1 it is 0, so I need not write that 0. Now we have differentiated this part. Yes, so we have finished differentiating this part. Minus, now differentiation of x is 1, so it will be this much. Similarly, this will remain as it is, that is log of root over x square plus 1 minus x is there. Now similarly you need to differentiate this one, so it will be into half x square plus 1 to the power minus half into 2x, because we have already seen here the differentiation of this, so that's why differentiation of this will be this much. So here this and this gets cancelled, similarly this and this gets cancelled, so simplify this. So we have this into 1 is root over x square plus 1, in the denominator we have x square plus 1 minus x, right? So this is 1 by, see, this is x is there, right? So this is x by root over x square plus 1, right? Minus 1 is there, minus, similarly we have x by, okay, so x into this is x log root over x square plus 1 minus x by root over x square plus 1. Yes, okay, let's simplify this. So if I simplify this, so let me write this as, so this will be as it is, so x square plus 1 root over x square plus 1 minus x, and this can be written as x minus x square plus 1 by root over x square plus 1 minus, now if you see this part carefully, this is equals to y, right? So that's why this can be written as xy, right? So this and this gets cancelled. Similarly, if you take out minus common, both will be same, so those two will get cancelled, so you'll have minus 1 out there. Okay, so this and this gets cancelled, so minus 1 is left, and from here minus xy is left. So if I take these two here in the left hand side, then I have x square plus 1 dy by dx is equal to, so this xy goes there, okay, so plus xy, and this minus 1 also goes there, so becomes plus 1 equals to 0. So that's what we wanted to prove here. So pause the video to note down. Now let's have a look at this question. Here we have been given that y is equals to tan inverse of this, right? And you are asked to find dy by dt, that means derivative of y with respect to t, right? Okay, so we have got t as the variable here. Now whenever you see tan inverse and you have got stuffs like this where you have got only variables, then what you can do is you can make substitution here, so that whenever you simplify this part you'll get tan theta. Okay, so tan theta you should get here. So to do that I'm going to do the substitution, this one. So let t square equals to cos 2 theta. Let's see what happens if we use t square to be cos 2 theta, right? Okay, let's check. So we have y equals to, therefore y equals to tan inverse of square root of 1 plus t square is cos 2 theta plus, similarly, 1 minus cos 2 theta by square root of 1 plus cos 2 theta minus square root of 1 minus cos 2 theta, right? So we have tan inverse. Okay, so we know that 1 plus cos 2 theta is 2 cos square theta, right? 1 plus cos 2 theta is 2 cos square theta, plus similarly 1 minus cos 2 theta is 2 sin square theta, right? So similarly we have 2 cos square theta minus square root of 2 sin square theta, right? Okay, so let us simplify this further. So we have tan inverse of, okay, so root 2 can be taken as common. So whenever root 2 is taken common, so here we have square root of cos square theta, that is cos theta. So we have cos theta plus similarly from here we have sin theta. In the denominator as well we have root 2 cos theta minus sin theta, right? So root 2 and root 2 gets cancelled. Now let me divide both numerator and denominator by cos theta and let's see what happens. So if I do that, then I'll get, okay, so if cos theta is divided by cos theta, then I'll get 1 plus sin theta by cos theta is tan theta by, again denominator also we are dividing by cos theta, so cos theta divided by cos theta is 1 minus sin theta by cos theta is tan theta, right? Okay, so this is equals to, now this is equals to tan inverse. We know that this particular thing is equals to tan pi by 4 plus theta, right? So tan inverse and tan can be cancelled, so you have pi by 4 plus theta. That means y is equals to, therefore y is equals to pi by 4 plus theta. Now your aim is to find dy by dt. Okay, so therefore differentiating both sides with respect to t, then I have dy by dt equals to differentiation of pi by 4 is 0, so no need to write. So differentiation of theta is d theta by dt. That means I need to find d theta by dt, so that has to be found using this. So from here, so we have 2 theta is equals to cos inverse of t square, right? This cos goes over there, so 2 theta is equal to this much. So theta from here is half cos inverse t square, right? Okay, so now we'll differentiate this with respect to t. So we have d theta by dt is equal to, this half is constant, so it will be kept as it is. So differentiation of cos inverse is minus 1 by root over 1 minus t square, but here already t is equals to t square, so that's why it becomes t to the power 4 into, now we need to differentiate this, so differentiation of t square is 2t, so this and this gets cancelled, so you have minus in the numerator we have t into 1, that is t by square root of 1 minus t to the power 4. So that's why d theta by dt is equal to this much, so that's why dy by dt, that is d theta by dt is minus t by square root of 1 minus t to the power 4. So this is our answer, so pause the video to note down. Next question is, find the differential coefficient of this with respect to t, tan inverse x. That means we need to differentiate this with respect to this. Okay, so whenever you see this kind of question, what you need to do is you will take this to be y. Okay, so let y equals to tan inverse x by 1 plus tan inverse x. Okay, and we will take this to be z. So z equals to tan inverse x. Okay, so basically you are differentiating this with respect to this. That means you are differentiating y with respect to z. Okay, so basically you need to find dy by dz, right? So if you want to differentiate this, okay, so you should have z here, right? So we'll substitute x with z here. Okay, we'll substitute x with z. So from here we see that z is equals to tan inverse x. So that's why this can be written as tan inverse x can be written as z by 1 plus z. So this is my y, and our aim is to find dy by dz. So differentiating both sides with respect to z. Okay, so this gives me dy by dz equals to, now this is f by g form, so f by g form is 1 plus z whole square, so denominator whole square, so denominator will be kept as it is, and we'll differentiate the numerator, minus, now we'll keep the numerator as it is and we'll differentiate the denominator, right? So this is equals to 1 plus z into differentiation of z is 1, minus here we have z, and differentiation of this will be again 1 by 1 plus z squared, right? So open the bracket. So whenever you open the bracket, you see that z and minus z, so this and this gets cancelled, so only 1 is left, so 1 by 1 plus z whole square. Okay, now ultimately what we do is we'll substitute the value of z, okay, which is tan inverse x. Okay, so this is equals to 1 by 1 plus tan inverse of x, because z is tan inverse x and we have got whole square out there. So therefore we founded our dy by dz, which is equals to this much. Okay, but ultimately what you need to write is, therefore the differential coefficient of whatever is asked, that is tan inverse x by 1 plus tan inverse x with respect to tan inverse x is, so you need to write this way, 1 plus tan inverse x whole square. So this is our answer. So pause the video to note down. Okay, now let us find the differential coefficient of this one with respect to this one. So as the rule says, we have to take this to be y and this to be z. Okay, so let y is equals to cos inverse of 1 minus x squared by 1 plus x squared. Okay, and z equals to sine inverse of 2x by 1 plus x squared. Now there's a direct formula in inverse trigonometric chapter, okay, inverse trigonometric function chapter. So there it says that this particular thing is equals to 2 tan inverse x. So this is a direct formula. You can refer that chapter to look at the formula, and similarly this will be equals to 2 tan inverse x. Okay, so both are equal, right? Okay, so we have y equals to this much, and similarly we have z equals to this much, and we want to differentiate this with respect to this. That means we want to find dy by dz, right? Okay, so we clearly see that this is also equals to z, right? Okay, so if I call this as 1 and if I call this as 2, so combining 1 and 2, so combining 1 and 2, I see that y is equals to z, right? And our aim is to find dy by dz. So therefore differentiating both sides with respect to z, let's see what happens. So we get dy by dz, and differentiation of z with respect to z is 1, right? So that's why my dy by dz is 1. So ultimately you need to write, therefore differential coefficient of cos inverse 1 minus x squared by 1 plus x squared with respect to sine inverse 2x by 1 plus x squared is how much? It is 1. So this is our answer. So pause the video to note down. So the next problem is we want to find differential coefficient of x to the power sine inverse x with respect to this one, right? So again, as usual, we are going to take, let y equals to x to the power sine inverse x and z is equals to sine inverse x, and our aim is to find dy by dz. Now z is equals to sine inverse x, right? So we'll substitute all the x with z. Okay, so from here we want to find this, and from here we have x equals to sine z, right? Okay, so let's substitute here. So we have x is sine z and sine inverse x is how much? It is z, right? So that means y is equals to this much, and we want to find dy by dz. But here both the power and the base contains the variable z, so that's why we have to go for logarithmic differentiation. So applying log on both sides, then we see that log y is equals to z constant, so we have log of sine z. Now let us differentiate both sides. Differentiating both sides with respect to, so we want to find dy by dz, so that's why I need to differentiate with respect to z. So the differentiation of this will become 1 by y into dy by dz, right? So this is f into g format, right? So f into g is z into dy by dz of log of sine z plus, now log of sine z will remain as it is, and we need to differentiate the other function, that is z, right? So here we have z into, so the differentiation of log is 1 by x, and x is sine z here, and into differentiation of sine is cos z. So we have used chain rule here, plus it will be log of sine z, and differentiation of this is into 1, right? So let us simplify this further. So sine, cos by sine is cot, so z cot z, plus this is log of sine z, so this is 1 by y dy by dz. But if I keep only dy by dz here, this y will come here and gets multiplied, right? So y is actually how much? Y is actually, okay, so let me write y for now. So let me ultimately put the value. So y is x to the power sine inverse x, right? So z is how much? Z is sine inverse x, and cot of sine inverse, okay, cot of z is again sine inverse x, plus log of, we have sine z is how much? Sine z is x, so it will be log of x. Okay, so this is my dy by dz. So ultimately you have to write, therefore differential coefficient of x to the power sine inverse x with respect to sine inverse x is this one. So we'll write x to the power sine inverse x. So from here we have sine inverse x cot of sine inverse x plus log x. So this is our answer. So pause the video to note down.